Okay, so the roof plan. We just finished doing the elevations and sections, so we proceed with the roof plan. Um, there's been some confusion among the teachers because some teachers were thinking that probably we're supposed to be working on one house. We're trying to complete the whole um, the whole construction drawing, but then other teachers are thinking of different exercises not related to each other. Uh, and I'm one of those because we have not really started doing it. That's why if you notice, the elevations and sections were supposed to be based on the floor plan, but since it was an afterthought, so the floor plan had to be, there were changes, no, done on the elevations which were not in the floor plan. So I decided that, okay, I'll just make my own, again, my own exercise for the roof plan. So roof plan is used to show the shape of the roof. It's as simple as that. Um, Sometimes this is incorporated in the site development plan. Although personally, I would separate it from the site dev because I want the site dev to show only the footprint. Okay, meaning to say only the walls, because if you put the roof on the site dev, so there's a part between the wall and then the edge of the roof which cannot be seen. Okay, so and we do not have any other way of showing what goes on after the walls. So in terms of design, say landscaping, so that's why I prefer most of the time that the site development plan should only show the building footprint, and then the roof plan is drawn separately. But don't be surprised that when you see that these two are incorporated. So materials such as the roofing material, vents, and their location, and the type of underlayment are also typically specified on the roof plan. So these are things that you cannot see anywhere, not even in elevation. And even though it's been seen in elevation, it's better appreciated in the roof plan. So several terms that represent common roof components must be understood before a roof plan or roof framing plan can be completed. So in the next succeeding slides, we will talk about each of these components. So we start off with abutment. Okay, it says here that an abutment is located where the surface of the roof joins with a wall or any other structural features. Okay, um, abutment is simply an extension or a projection away from, say, a wall. So in the drawing you see here, there's an abutment, so an extension of the roof. Okay. And then chimney flashing. Well, in the Philippines, we don't have chimneys, although sometimes there are architects who put up chimneys for decoration purposes only, just to make it look like a cabin or something else or European. But if you're in designing for Baguio, where they're taking the architecture profession very seriously now, um, chances are you will end up with a house with chimneys. So this is flashing that is usually laid in multiple strips underneath the shingles near the chimney. Then they are bent up towards the chimney. So a flashing is actually just a covering, although we will talk about flashing later on. So it's a covering to uh, for the gaps between two joints. Okay, so that um, there won't be any leak. Next, dormer. Okay, so a dormer contains a window that projects vertically away from the rest of the roof. This is used to create an extended window in the roof itself. This is commonly found in loft conversions and is used to increase the amount of natural light in the room. So if you have a window on the roof, most of the time it comes in the form of a dormer. So if you have a loft, so you put a window and then it's a door. So it looks like this. It's like a small house on top of the window. So this is very common. And so that's what it's called. Sometimes it can be very, very big so that it actually is like a terrace. But I don't know if there's another name if it's that big. But technically they're dormers. And then downspout. So the downspout is a channel that is used to transport water from the gutter down to the ground level and away from the house. Okay, so you have a gutter, but then there has to be a hole in the gutter, although it collects the rain, but then it has to channel the rain or the water towards that hole, but then it cannot just fall freely. It has to be channeled also. Otherwise, there will be the water will splash anywhere, and you don't want that. No? So that's why there's a pipe from that hole leading to the ground, and you will appreciate this more in your plumbing subjects. So this is a downspout you see here in the picture. A drip edge is a strip of metal that pokes out beyond the eaves. It prevents rainwater from rolling across or around the shingles back to the house. Okay, um, the drip edge is here. So at the end of your roofing, you either have a gutter or you don't. Okay, so if you don't have a gutter, so the rainwater will fall freely to the ground. But then if it is very near, the edge of the roof is very near the fascia or the, say, another surface attached to it, perpendicular to it, chances are the rain will creep. It will not fall, but it will follow the surface. And it will even go up towards the house. We call this the capillary effect. Okay, so the water seems like it's connected to the surface, and until the gravity cannot hold it, until it cannot hold its own weight, so it falls down. But depending on the effect, the velocity might even help of the velocity of the water might even help make it creep towards the under the eaves and then towards the house. So that's why the roofing is projected way beyond the surface, the other surface, so that even if it goes up, so something stops it and then it falls down. This in some walls, this there's a molding which is called the drip molding. Okay, so it works like that. If the wall is flat vertically, you put the molding, and the molding actually looks like it goes down and then it goes up again, and then uh, like that, simply, so that the water does not go all the way to the surface, but actually falls down away from the surface. Um, so that's the drip edge. Then the eave, since we mentioned the eave, it's the lower edge of a roof. It usually overhangs beyond the edge of the house itself. So you have the eave. So you have the wall, and then you have the roof, but then it extends a little farther, and that portion from the roof or from the wall to the edge of the roof is the eaves. Okay, so it's the overhang. Well, some people would simply call it overhang, but technically for architects it's called the eaves. And then fascia is the trim board that is located behind the eaves and gutters. So I mentioned to you about the roofing, and then there's that wall, that surface. Normally, that's a fascia. Okay, um, so it's like a so it's a trim. It's like it's just a a piece of wood, or maybe sometimes it's metal. Uh, its main purpose is actually to cover your the wood that represents the roof frame, because from the wall you'll have some wood projecting or steel projecting from it before you put the roofing. And so if you don't have a fascia, you'll see all those projection, no? The which we call the rafters. I mean the purlins. You see the edges, so you cover that, and then uh, that's the fascia basically. Flashing. Okay, here's the definition is made up of sheet metal or other materials. It connects junctions, no, connections to prevent the roof from leaking. Okay. So the idea here is that, for example, in this shed here, flashing, um, so it's like your masking tape. You have a cardboard which represents the shed roof, and then you have another cardboard representing the wall, and then you cover the connection with the masking tape. Okay, but then you're going to argue that, okay, sir, if the water creeps along the wall, it can still go inside the flashing. That's true. That's why the flashing is normally placed before you plaster the wall. Example, if it's a hollow block wall, so the flashing is placed there first, and then you cover it with cement plaster, so that water goes to the cement plaster, okay, creeps to the cement plaster towards the bottom part of the flashing, so it does not go inside. So that's how it's done in construction. It's the same here in the chimney flashing, especially when the chimney is made of bricks. So the flashing is inserted under the bricks, okay, so that the water does not go inside the flashing. A flat roof is a section of a roof that has a consistent degree of elevation across its entirety. So it's very easy to understand what a flat roof is. It does not have any ridges or valleys associated with it. So we'll learn about ridge and valley later. But a flat roof is not actually flat. It should not be really flat. No? Um, I mentioned to you earlier, I call this as a shed, although, well, technically it is, no? But with a flat roof, my point is the flat roof has to slope a little away from the house, okay, so that the rainwater will still uh, drip or will flow also away from the house. And normally that slope is very small, only 2% slope. Okay, this is the same percentage of slope for pipes. If you have a vertical pipe and a horizontal pipe, that horizontal pipe is not really horizontal, it's sloped a little, so that the water going through the pipe will have to continue flowing. Otherwise, it might remain stagnant inside. Then gable or rake. Okay, so we have here in the drawing the gable or rake. This is the slanting edge of a roof that extends beyond the end of the house. Okay, so if your house has two um, two sloping sides for the roof, only two, so we call that a gable roof. If it has four, uh, we call that a hip roof. We actually have a term here. Okay, so the gable part is the edge. No, it's slanted. So in your history, for example, Um, you have what we call cornice in the Roman architecture, but then in the temple, that cornice would slant, because the temple facade has a triangular, the pediment is triangular. Um, so therefore, that cornice is now called the raking cornice. So meaning to say it's a slanted cornice. So the gable end, well, we can easily understand, is the triangular portion of a wall that closes the end of a ridge roof. Now, sometimes this triangular portion of the roof is flushed to the rest of the wall. It forms one surface, but sometimes it's also projecting, depending on the design of the architect. The hipped edge is at the edge of a hip roof. So what's a hip roof? And it's located where the slopes meet the walls themselves. So this is the hip edge. Basically, the hip, which is the next term, is the external angle that forms at the junction of two sides of the roof. So you have two sloping planes or surfaces intersecting each other at 90 degrees. So the result is a slanted and angled line. That's the hip. Okay. Um, it's like the an oblique line in our previous lessons. So a gable, a rake, for example, is like an inclined line. If we face the wall, so it is parallel to our vision, our uh, plane, no? View plane. So we call that, and we can measure its true size, true length. Therefore, it is inclined. But then when you turn it around, that's the time that it becomes like oblique or hip. So there's another name. The name we used in Visaya for hip roof is, I think, cuatro cantos, four corners of that. And for gable end, it's dos cantos. Um, and then if you have a roof which is just projecting from a little from the wall, like to cover only the window, uh, it's not cantos, no? Because cantos means the wall. It's cuatro aguas or dos aguas because that roof that I mentioned projecting only to protect the window, they call it media agua. Okay, so the agua is water. It's referring to the roofing, and the cantos is the wall. Refers to the wall. Uh, these are all Spanish terms. Okay, so rain gutter. Um, the rain gutter is the part of the roof that collects water and moves it away from the structure. We already mentioned that earlier. We sometimes just simply call it gutter, no, not rain gutter. Ridge is the horizontal line that is at the top edge where two roof planes come together. So it's at the summit. So you have two uh, roof ang angled surfaces, and their connection at the top is the ridge. Okay, it usually has a slightly different texture from the rest of the roof. I don't know what that means. Okay, but what is not in here is the covering for that connection, because we have flashing, but what you cover the ridge is not flashing, because the flashing is like a it forms a V like that, no, or something like reversed. But then if it forms the reversed V, we call it a roll, ROLL. So the covering for the ridge is a ridge roll. Okay. I don't remember seeing that term here, so this is not complete. So ridge roll. A sidewall is a place where the roof and the wall intersect. They are sometimes called head walls. Okay, so nothing to explain there. And a skylight is a window that is installed on either the roof or the ceiling, while it can be used for stargazing. It is usually used to increase the amount of light in the room during the day. So the difference between a skylight and a dormer seems obvious, no? The skylight is just like really a wall on the roof, but then made of glass. I mean a hole, no? In the Philippines, we don't do stargazing using the skylight. Maybe in some very, very rich subdivisions. Um, but we use skylight mainly to let in light, especially if this is already in the interior, deep into the house, no? And then there's no other source of light. You cannot put a light well for some reason. So another way of letting in natural light is through skylight, although it would be filtered already, no? Because you have the glass and you have the diffusers. Soffit is a set of boards that enclose the underside of that specific portion of the roof. The soffit is used to protect this portion of the roof as it extends beyond the house. Normally, the soffit applies to the eaves. So the eaves, I mentioned to you that, well, it's a projection from the wall, no? But then, before you even put the roofing, I mentioned to you that there are roof framings. Okay, so you cannot have that exposed. So when you cover it, especially the underside, we call that the soffit. Okay, it's the roof, it's the ceiling of the eaves. It's like the outdoor ceiling. Valley is like the opposite of the ridge. If the ridge is like this, so the valley is like that. Uh, so it's a V, it forms a V. So the valley is a point of lower elevation or the bottom edge where two roofing sections come together. So the valley is the opposite of the ridge. I just mentioned that, no? Here. Um, in the valley, although this is a connection between two surfaces, we do not put a flashing, and we do not, yes, we do not put a flashing. What we put instead is a valley gutter. Okay, we put like the flashing underneath that serves as the gutter, so that rainwater, when it comes, it goes to that gap. It goes under the gutter and then is channeled away down to the actual gutter, you know, along the edge of the roof. So again, this illustration lacks another term, no? Aside from the ridge roll, it lacks that valley gutter. Okay, I feel like something else was missed. Okay, the hip. There's another term which was also missed out in this illustration. Um, since the hip is a connection between two sloping surfaces which intersect at 90 degrees, so you have another connection there. You have to cover it. This time it's also a roll, no? So if you have a ridge roll, then you also have a hip roll. Okay, and then you have to include that um, in your estimates, for example, and also specify that in your drawings. I think that about covers it. Okay, so how do you draw a roof? A flat roof is very easy to draw, so we don't tackle it. And also a gable. The more difficult roof to analyze is the hip roof. Therefore, our examples and your exercise or your homework will be about a hip roof. So here, we are given a floor plan layout of a house. There are two widths, no? And this width at the right is 4 meters, and then the width of the side below is 3 meters. So our task is to make a hip roof. So this is just the perimeter of the house. So first, what we do is we draw 45-degree angles or lines from the corners. Okay. Draw in the hip roof, draw lines at 45-degree angles from the points on the roof as shown in blue. Note that the two lines to the top left of the image are just drawn in. Okay, so it's not completed. So the ones in this corner, the left corner, um, their length will be determined in the next step. So all the other lines making up the hip can be calculated by joining them where they intersect. So at the side where there's the dimension of 4 meters, so the two 45-degree lines intersect, so that ends that angle. No? And also that's what happened at the bottom. Then step 3, add in the ridges. So the 45-degree lines earlier represent the hip, no? The edge of the two sloping surfaces which intersect at right angles. Therefore, when they intersect, that's the top point of the roof already. That's the ridge. So add in the ridges line starting from where the hip that are established join. Then trim off the valley line and hip line lengths that were unknown from the previous step. Okay, so you have on the upper left, you had a line which was just drawn in, and then it intersects with the ridge that we just drew now. So that intersection marks the end of that hip line and also the valley line at the bottom. Okay, and then finally, we join these two intersections to complete the roof. So this is now the complete roof. We have to put in what they call the fall direction. Um, in our case, we call it slope direction. It's sloping down. Okay, so we put an arrow, and sometimes we put slope, but even if we just put an arrow, that's enough. That indicates that, okay, this surface slopes downward. So that's what it means in construction. So very easy. So let's make it a bit harder. The floor plan earlier, this time with an extra piece added here. So we added 250 millimeter at one side, and then 500 projection the other. So now this is our plan. So we do the same thing, put in 45-degree lines. So if they intersect, so that ends the 45-degree line. So we have identified the hip, the ridge here. But then otherwise we just draw in, and then we just wait for the next step to determine where it should end. So in the next step, we put in the ridges, and then it intersects with the 45-degree line which were drawn in, which here in this case are the valleys. So next is we put like a imaginary box, no? Draw in the 45-degree angle lines representing the hip in dashed lines. So we think of this and that corner to be corners of one big rectangle, and then we sort of make the 45-degree line also from these imaginary edges. Okay. The other two lines, the horizontal and vertical line, are drawn to make an imaginary box. These lines help to show you where to start the hip from. And then say where it joins the ridge line, so it continues to be a solid line until it intersects with the hip line at the other side, and then that locates a ridge, another ridge. So we do the same with the other side. So the rest of the line, if we drew it in pencil, we can now erase it. Okay, so delete these dashed lines, it says here. So this is now our final roof. Okay. Um, I just realized that the this example did not have an eaves. So therefore, we have started actually with like the edge of the roof instead of the edge of the walls. Example 3. There are 4 examples actually. So we make it more complicated by cutting a part of the corner in the upper left. Okay, we cut off 1000 by 2000 millimeter on the corner. And then we still do the same. So it's the same process. So here we can complete the roof, but here we just drew in. So the direction is always going towards the inside. Okay. From here you go towards the inside, here go towards inside, and here going towards. So you don't draw to the other direction. It's going outside. And also here it's you don't draw to the other direction because this is like going out. It's not going in. And then we put in the ridges again. And then we try to complete a, a roof of an imaginary portion of the house which forms a rectangle like this. And take note where the hip of that imaginary roof intersects, say, the valleys or the hip drawn earlier. So what happens here is that, okay, so there's this valley and then there's this one. So we draw in that. And then we draw another rectangle because there's also a like a rectangle here. And then we complete the roof and we take note of where they intersect the this other side. No? So let me see. And so we have this. So this is getting complicated. Okay, let's see if I can explain it to you properly. We also have this completed here. And then we put in the ridges. Okay, so here there's no problem. I think the problem is more of this portion where you have a ridge between two roofs. So it's like there's one complete roof intersecting with one complete roof here. And so this is the intersection. So you just have to analyze it. It's very difficult to explain um, how to analyze it. No, um, but when you follow the lines, so this hip, for example, ends here and it's supposed to go down. So it should either end here or here. But then you have this valley and then it's supposed to end here to get, so this should be joined. Because otherwise, if it ends here, so this is now ambiguous. Okay. So draw in the ridge lines and then this is the finished floor. We forgot to put the slope or the edge, the fall, or maybe I forgot to copy it. The last one, we try to complicate it more by cutting along the sides. Okay, here's a cut here, and then a cut here. Now, in this solution, the approach is different. Instead of drawing the 45-degree lines, we draw imaginary rectangles that forms the whole composition. So we have drawn it here in different colors. No? Here's a yellow rectangle here, and a green rectangle here, and a red one, and then we have a purple one here, and then a blue. We have two blues. I think they're supposed to be different in colors. So they form the outline of this roof. Okay, and that's when you start putting in the roof of those rectangles, and then you start out with the whatever is along the periphery. This one is right in the middle, so you put that later. So this one is complete. This one is at least this side. This side is complete, and then this side. So and then put in the roof of the one in the middle, and then you analyze now the intersections. For example, here, so this intersects here, there should be a valley, so it ends here, okay? And then this, there should be a valley here and intersects with this, so it ends here. So therefore, there should be a ridge from this to that, which we show later with this, okay? And then from here, we have a valley which intersects this one, and then it continues like that. So and it continues even further. Okay. Mm, okay, so this is getting more complicated. Yep. So I was looking for this because it's if it continues further, there should be another line here. Okay. So when you put in the ridges after analyzing all the valleys, you see that some parts are not complete. This one is not complete here, and this one is not complete. But then the rest, make sure that they are logical. Okay, this is one surface, and then it slopes down, and then forming 90 degrees to it is another surface and slopes down. So this is okay. So this is supposed to slope down, and this is supposed to slope down, but then this one is supposed to slope down that direction, so there should be something here. Okay, so that's when you start analyzing, and then you put in 45-degree at this corner, and then also so because there's another sort of imaginary box that we fill in here. And then since this valley ends here, so it's supposed to, and it's not a ridge continuing, so there should be a 45-degree line going inside. Okay, and then there's a valley that ends here, then there's supposed to be a 45-degree going to this side, not down or not below. No? So, and then that 45 degrees from both valleys meet here, so there should be a ridge here, and then it connects with the other valley. Okay, so in the end, this is how it looks like. We erase all these gray lines, which were imaginary, and so we complete the roof. Okay, so that didn't sound very clear. So it needs analyzing. It needs analyzing. Okay, so if you are going to, for example, put lines along the surface going to the direction of the fall. So in principle, when they meet with another surface, if you put lines, so they should there should be an angle. Okay, so where the two lines meet. No? So sometimes that also helps. That will also help you analyze if you put in those lines. at least you imagine those lines exist. So for example, here on this portion, when we were, if we imagine those lines, it's like a hatch, no, vertical hatch here and a horizontal hatch here. So definitely there should be a corner here where they meet. Okay, so that's the valley here. So that's how we analyze it. Um, so that's how you compose the roof. Don't worry, your exercise is not that complicated, just a little. So how do we actually draw? So when we already make that into an architectural drawing, I only have one sample so far. I was trying to look for a finished sample in the internet instead of making one myself, uh, because it takes a long time. And I could only find this, which fits what I want. So let me see. Here you see a dashed line somewhere inside the edges of the roof. Now this represents the edge of your walls. This is the outline of the wall. Okay. So please take note that the overhang is not always the same. Although normally we would just have the same width for the overhang or the eaves, but you can design it such that some portions of the wall projects. Therefore, for example, this part here, probably this is a bay window. It projects farther, but then the roofing does not necessarily need to follow it. Okay, so it's part design. So here I think maybe this part here is maybe is a terrace. I don't know, but you should not draw in the whole floor plan in a roof plan. Only the edges, only the perimeter wall, the edge of the perimeter wall, the outer edge. You don't even draw in the wall to be thick, no, with the thickness of the wall. Just one drawing. And then you're supposed to label that. It's not done here. And you're supposed to indicate that this is outline of the wall below. Okay. Just in case you encounter a foreman or an engineer who does not know how to read roof plans. It happens. It's unfortunate, but it can happen. Um, so here he has the fall. There's an arrow. I mentioned to you that you don't need to write anything else. In our previous example, they put the word fall, and I also mentioned that you can put the word slope instead because it's more understandable in the Philippines. But in this example, what he placed is the slope in terms of proportion, in terms of a fraction. Say, a fraction of, I think, 8 is to 12. So like 8 for the x and then 12 for y, and then the angle you get from that is the slope. Okay, but you don't need to put that. If you want, you can also put the degrees if you want, but you don't need to put that. You can just put an arrow. It's the simplest. Now in this drawing also, the ridge roll, the hip roll, even the gutter is not drawn in. Okay, in the Philippines normally we draw that. Okay, why? Because it makes it more representable, like it's easier to understand. And depending on the scale of the drawing, if the drawing is small, you can put in the actual material, like if this is supposed to be, I showed you example last time where the roof tiles is actually drawn, the whole part, or you can draw in lines to represent the galvanized iron sheets, no, the scene. what we call the scene. Um, or you can just make a circle or draw a portion to indicate that, okay, this is the material, and then you call that out. Um, so this is very typical in the US to have a very abbreviated drawing. So what you should do when you're already working, especially if you're working in a large company, you have to know their standard. Do not impose your own. For example, in this class, you come up with your own style, and then you've been consistent throughout your 5 years in architecture. But when you work for a company, you have to adjust to their standard if they have. Okay, if they don't, then probably you can start setting the standard yourself. By that's the time that you can impose your own. So if the standard in that company is just to draw it as simple as this, you should follow. Okay, otherwise your job captain or your architect will feel frustrated with you. Okay. Now homework. Homework is as simple as this. So given the building outline, so this is the building outline, not the roof outline. Then the grid here is 2 meter by 2 meters. Draw the roof plan using a hip type of roof. Show the gutters, ridge roll, and hip roll. Okay. Draw in ink on A4 or short bond paper at scale 1:100 meters. And there is no need to draw the grid, which you see here in the final output. So um, your task is just to draw the roof from earlier. Um, Please, again, take note of the alphabet of lines. Okay, so the main divisions of the roof, like your hip, the valley, the ridge, should be medium line. The main outline of the roof can be a dark line. And then the other parts, which are the gutters and the valley roll and the hip roll and the ridge roll can be made of, should be made of fine line. Okay. And then don't forget to indicate the slope directions. You can just do that with a simple arrow, not an overwhelming arrow. And then also indicate the edge of the building walls by a hidden line or dashed line. Okay, so those are pointers. Uh, Very good. So that's it for today. Is there any question? Mm, I will also make the no need for eaves. Of course, there's an eaves. Okay. So I need to specify the eaves. Okay. Um, I forgot to put in the eaves. So the eaves, the edge of the roof should be 1 meter away from the wall. Okay, it's 1 meter away from the wall. Therefore, the eaves is 1 meter. So very good. Thank you for reminding me. Um, so what you do from that outline, like if this were AutoCAD, you offset by 1 meter and then start the roof that way. Okay, so it's 9 o'clock. It's almost an hour. If you have any questions which you can remember to ask only later, so you just drop me a note. For now, we end this session. So I'll wait for the exercise to be uh, posted on Canvas. Okay, so have a good day. Goodbye. Okay, thank you.